In this module, we'll also have a look at a couple of new features, or to put it in better words, new behaviors, I should say, but we'll not introduce that many new features as in the previous modules. This, however, is a very important module because we'll have a look behind the scenes of JavaScript. We'll understand more how it works, what the browser does with our code, how it executes our code. We'll also have a look at a couple of weird parts in JavaScript and how it evolved over time. And we'll have a look, and that's related to the evolvement process, we'll have a look at ES5 and ES6 and what that is and how that differs. Now, to be precise, we'll actually start with that ES5 versus ES6 thing, and I'll explain what that is and how the syntax changed in these different versions of JavaScript, which it effectively is. We'll have a closer look at how some of the syntax, especially when it comes to creating variables, changed over time and what a key difference is between how we create variables now, which is how you learned it in this course thus far, and how we did it in the past. We'll then have a look at how JavaScript works. So what the browser actually does with our code, how it parses and interprets this, and then also how it executes the code. So once it interpreted it, or once it started interpreting it, what it's doing with the code. And we'll have a look at a couple of weird parts with JavaScript that can be confusing, but that actually aren't that confusing. You just need to be aware of them. And I'll dive into all these important things in this module. So what's up with this ES5 versus ES6 thing? Now, ES stands for ECMAScript, and you might remember from section 1 that ECMAScript in the end is the language behind JavaScript, so to say. You could say JavaScript is a specific version of ECMAScript, of course, the most important version. So ECMAScript in the end is the language being standardized by this ECMA international body, and these are the guys, and of course in that process there are many people working at the common browsers involved. So these are the guys who work on new iterations of ECMAScript and therefore of JavaScript. So they decide what ends up in the language and what not, and then the browsers adopt this into their JavaScript engines. This is something I already explained in section 1 of the course. On this ECMA international page, you can always dive into the ECMAScript specification. This is the technical description of how ECMAScript and therefore JavaScript should work. And yeah, you can really dive into that, but to be honest, this is not a resource you'll commonly work with. This is mostly important for browser vendors who need to make sure that their JavaScript engine follows this ECMAScript definition. So that is what ES stands for, ECMAScript. Now, ECMAScript, and therefore also JavaScript, is still under active development. So people from the different browsers and also other people involved in that process are still working on the ECMAScript and therefore on the JavaScript language. They're thinking about new features that could be added to make it better, on maybe fixing some things that don't work as expected. And as you can imagine, since JavaScript is that widespread and since people use that many browsers, of course that is a process that has to be done with great care, because you can't change the language such that suddenly existing web pages stop working in older browsers. So you can basically only add new features, you could say. You can't really remove existing features. At least that is very, very difficult to do. So over time, ECMAScript and therefore JavaScript evolved. It dates back into the 90s, of course, when it got started, but then we had a slow evolvement and it became more and more important. And one major version that was released in the past was basically ECMAScript version 5, you could say. And this is just a term that was assigned to one specific version of that standard that was released and that was agreed on, you could say. Now, ECMAScript 5 included some important improvements and most importantly, standardizations back then, because before that, a lot of browsers basically did what they wanted, and this was the first real big standard after ECMAScript 3, which also went into this direction, where the browsers could agree on and where we then had one common ground for browsers to implement features. So that was really important. Now, one other very important major version, which was kind of finalized in 2015 and therefore is also known as ECMAScript 2015, or also another version number assigned to it, ES6. So another major milestone was released in, or was finished in 2015, and from that point on slowly integrated into browsers. And that's also important to understand. Just because there is a new standard, a new draft on which the people involved in this standardization process agreed on, does not mean that all browsers suddenly ship all these features. Instead, features are getting added to browsers incrementally, so step by step, and at different speeds. And old browsers, so for example Internet Explorer version 9, of course don't include these new features. Now that's a totally different topic, and I'll come back to that in the browser support section of this course, where we talk about supporting different versions of browsers, especially also older browsers, and still using modern JavaScript syntax when writing the code. This might sound impossible, but it actually is possible, and I'll cover it later. So what you'll learn in this course is really something you can use, and which will even be usable by users who use older browsers. So that's just a side note. ES6 was another major mark in the development of JavaScript, and since then more features have been added. We just don't have these striking new version numbers. Instead, now it's more of an incremental process where we have basically small advancements that are integrated by browser vendors step by step. So ES6 and later is what this course teaches from the beginning on. Because we have some huge syntax changes from ES6 to ES5, and as I mentioned earlier, changes really means new features added, not old features removed. So you could still use the old syntax, the old features, but ES6 introduced many new exciting features, and since then many more exciting features have been added. And again, in this course we only use this modern JavaScript syntax so that you learn the latest version of JavaScript. Now, as I mentioned, the ES5 and older versions of course have great browser support, including old versions of Internet Explorer, because these versions have been around for much longer. But for example, one major difference which we have in there, which I'll come back to in the next lectures, is that in ES5 and older, we only had a var keyword for creating variables and not let and const. This might sound like a minor thing, but it's a huge thing actually, as you will learn in the next lectures. And it's one of the most important changes from ES5 to ES6, though there also are a couple of other exciting changes. Generally, of course, JavaScript still is the same language there, but again, ES6 and later versions introduced many exciting new features. Now, what about browser support for ES6 and later? Well, modern browsers have pretty decent support. Also keep in mind that all these modern browsers, and that includes Edge, of course, have an auto-updating functionality, which means people don't have to manually install new browser versions, which was the case with older versions of Internet Explorer, and therefore features can be integrated into browsers at a much faster pace, and more users will automatically use these latest versions of browsers because the browsers themselves automatically update. So that's really cool. So we have great support for all these modern JavaScript features in modern browsers. So basically any user who uses Chrome, any user who uses Firefox, and most users using Edge have access to these features. And again, in the browser support module later down the course, you'll learn how you can even make sure that people who are not using such modern browsers can still work with your web page that uses modern JavaScript syntax, or where you use modern JavaScript syntax to build it. So we have great browser support in modern browsers here. And the cool thing about ES6 and so on, as I mentioned, is that it introduced many new features that in the end all aim to help us write cleaner, better, and faster code and need less workarounds or hacks. Because with ES5 and older, you had quite a lot of situations where you needed hacky workarounds, where you needed a third-party package, which in the end just implemented the hacky workarounds then, to solve common problems. So it was easier to write bad code with that older version of JavaScript, and many of the new features introduced with modern JavaScript with ES6 and later simply make it easier for us to write shorter, cleaner code. Now, as I mentioned, it's still under active development, but ES6 was simply a big milestone. It's not like the latest version and nothing happened thereafter. We have a continuous development process there. We just don't have these big labels on all these new versions. Instead, new features are getting added to the ECMAScript specification all the time, and then browser vendors, so the people behind Chrome and Firefox, start implementing those into their JavaScript engines. So that's the JavaScript evolution. Now, I did highlight that var, let, and const thing. What's up with that? In this course, you learned that you can create variables with let and const, and the difference is that variables created with let are changeable, variables created with const are constants, and therefore not really variable regarding the value they hold, at least not after they have been created. Now, it turns out there actually is also a third way of creating variables, which I haven't taught you thus far, and you'll see why I haven't taught it in these lectures here. You can create a variable with the var keyword as well. So besides let and const, that is also available. Var creates a variable just like let does. And the only difference we can clearly see right now is that const creates a constant. So var indeed, just like let, creates a variable which you can really change. Which of course raises the question, why do we have var and let? If they do the same, why do we need these two different keywords? Well, turns out they don't exactly do the same. Now let's first have a look at availability. And there, var has been available since ever. This is the way to create variables since JavaScript exists, essentially. Let, on the other hand, is only available since that ES6 version, so since browsers started to adopt that. And it's the same for const. So that's a difference, but this only explains since when we can use these features, not why we need let. Now that, on the other hand, can be answered with this last comparison here. Var allows us to create variables in the function and global scope. And that's something you learned about in this course already, right? And you learned it for let, not for var. Well, turns out, actually let does not really use function and global scope, although in many cases it behaves exactly like that, but it uses a concept called block scope. And the same is true for const. So let's now dive into block scope and find out how that differs from function and global scope and what that means for you and for the way you write your scripts. You can spin up a simple project for that. Attached, you also find a dummy one. This is simply an index.html file with nothing in it but a script import in the end. Script import to this empty app.js file. And in there, let's write some code. Now, I did mention that any variable you create with const or let outside of a function is global, and any variable you create with const or let inside of a function is local, so it belongs to that function and can't be accessed from outside. Is that false? No. The good news is that is totally true, so what you learned is true. There's just a bit more to const and let than what we covered thus far. And for a good reason, because that can only be fully explained now that we also know if statements and loops. So let's start simple. Let's add a variable name here maybe. Good old name Max, or your name of course. And let's add a function, and we can say greet here. And in this function, if I console log name, then you learned that of course, if I call greet here, we actually will see Max being printed out in the console. Let's quickly validate that by going to that page, opening the developer tools. And there, let's go to the console. And if I reload the page, we see Max here. Now that's not too surprising, that is something we learned before. Now what you also learned is that you can go into a function and create a variable in here, let's say age. And if I now also output that, this will also work, but what will not work is if I try to output it from outside of that function. So if I try to output name and age down there, name will work because that is a global variable here, but age will actually not work. So if we save that and we then reload, you'll see I get an error, uncaught reference error, age is not defined in line 8, and that's exactly this line and exactly this variable. Now on the other hand, if I delete this here and I don't try to output age here, and we reload, this works. This is from line 5, which is inside of our function, this log here, and from line 8, we only print the name. So that is working, and that is what we already learned. You also learned that you can shadow variables, so that we could redeclare a variable in here inside of a function which we already declared outside of it. If we would try to declare an existing function here, then we'll actually get an error. So if I try to do that and redeclare name after declaring it here, if I now reload, you'll see I get an error because the identifier name has already been declared. But if I delete this line here, and we now reload, the script works just fine and we print manual inside of the function. So redeclaring the variable name here does not hurt because this is locally inside of a function, and therefore JavaScript actually shadows this outside variable, which means it kind of overwrites it, but only inside of this function. It simply ignores this outer global variable, you could say. So that is what you already know. Now what is new? Actually, as I mentioned, variables and constants created with let and const are block scope. var variables, and var is that keyword which we haven't used before, are function and global scope. So therefore, in everything we learned thus far, you could absolutely replace let with var, like I did it here. I replaced let in all three places with var, and you would get the exact same behavior. If I reload, I get the exact same output. Now, one first difference we can see here, by the way, is if I try to redeclare this. So here, where I declare this again after already having declared it, this will actually not throw an error. So here we already see a first minor difference, though that's not the main difference I want to dive into right now. But this already is a little thing where they differ. And arguably let is better here because we want to get an error in such a case. Because if we redeclare a variable which we already declared in the same scope, that typically is not what we want. We maybe want to assign a new value, sure, but we don't want to recreate the variable. That's not something you would ever want to do. So that's a first difference, but not the main difference. The main difference is really related to the scope. So here we have this function, all great. And let me try to output age down there, so a variable which only was created inside of the function. And if I now reload, you'll see we still get that same error. So phrased a bit differently with not being defined. So the declaration is not the problem, but the definition. But generally, this still doesn't work. So no difference there. Now we can see a difference if I change something. Let's say we want to add an if check here and check if name is equal to max, which it here of course is. So we will make it into that if statement here as long as name is max. And then in here I create a new variable, and this variable simply is a hobbies array where I have sports and cooking, for example. And I can then console log my hobbies here. And now let me also try to log my hobbies down there. Now this is not a function, this is an if statement, right? That's really important. This is an if statement, not a function. And I'm using var. So now if I save that and I reload, you see we get no error. Instead here we print the array. That's from line number 5, which is this line here in the if statement. And we also print the array here. And that's coming from line number 14. And that's outside of the if statement down here. So maybe you expected that this would not work because the variable is created in an if statement. But what does this mean? Well, since it is not in a function, and the if statement also is not in a function, this simply means that this is created as a global variable. So it means that this really is now a normal global variable as if we would have defined it out there. So therefore, anywhere in the code where we can access global variables, which basically is everywhere, we can use hobbies. That of course includes our function here, just in case you're wondering. If I try to access hobbies there and I reload, that will also work. We're outputting it down here. So that's interesting. Now let me change this var here to let. So only there, all other variables are still created with var, though you could change them to let as well. But the hobbies variable is the important one right now. So I changed this to let, and of course you could also change it to const because we never assign a new value. That's not what this is about here. So you can use let or const here. Don't use var, that's the important thing. And with that changed and saved, try reloading. Now you get an error. We get that log from line number 5. So this log here works just fine, as we would probably expect because we declare and create the variable in the line before that. But thereafter we get an error stemming from line number 14, which in the end is this line where we try to access hobbies. And that's the difference. var only knows global scope and function scope. So a variable created in a function can't be used outside of it. A variable created globally can be used everywhere. Now for let and const, this also is the case. Variables and functions can be used in functions. Variables outside of functions can be used everywhere. But actually, Let and const don't care about functions, they care about the curly braces. And functions happen to have curly braces here, so do if statements. And of course, I'm not talking about the curly braces you have when you create some object, right? So if you create a person here and you have the curly braces here to create an object, I'm not talking about those. I'm talking about the curly braces you have for if statements, for loops, for functions. So not for this object value which you're creating here. You can't create a variable in here to begin with because that would be invalid syntax. Here you need key value pairs. So just to make that clear. But any other curly braces you have in your code, so if statements, loops, functions, try-catch blocks, if you create variables between the curly braces with let or const, then the variables are scoped to that block. So the curly braces mark a block in the end. And therefore they are only available in that block. They don't spill outside of that block. And that is a key difference. And that is great because that gives you more control over where your data is available. You want to use it everywhere? You want to use hobbies everywhere? Well, simply declare it here and only assign a new value in here. This will work because from every block you can access all variables or constants defined on a higher level. So in a block around that block, be that a function or be that your main script. But you can't, just as for the function global scope you learned earlier, you can't access variables defined in some child block, so to say, so a block on a lower level from outside that block. That does not work. So you have more control with that block scope thing, and it can also avoid some nasty issues or unintended behaviors which you had with var in the past. That's why with modern JavaScript, as we're learning and using it in this course, you only use let and const. It forces you to write cleaner code because you get an error if you want to use your hobbies down there and you only declare them here. Because that simply is incorrect code, and that's good. It forces you to find a solution like the one I just showed you where you define it here and assign a new value here. So it forces you to write better, cleaner code which is clearer about your intentions. It's actually a bit unexpected that you would want to use hobbies down there if you define the variable inside of an if function. Because if you define it, and with that I mean you use the let keyword or the const keyword, if you define it in an if function or in a loop, the first thing I would think as a developer is that you probably only want to use it there. Otherwise you would have created it as a global variable, right? So it forces you to be clearer about your intentions, and that's always a good thing because it leads to cleaner code. So that's the thing behind let and const. And as a consequence, we really don't use var anymore. Only work with let and const in modern JavaScript. Don't use var. There really is no use case where you would need var anymore. So why is var still in the language then? Well, because of that browser support thing. You can't remove it because that would mean if Chrome decides to not support the var keyword anymore, that all scripts that still use var, and that will be many scripts around the world on different web pages, stop working. And that might not be what you want if you're working on the Chrome team. So that's why we still have var, but we don't use it anymore. And the difference is the block scope. Now, a little side note, the block is really just created by the curly braces. So you could theoretically also put curly braces here. This does not create a JavaScript object because it's not on the right side of an equal sign. So it's not used as a value here. Instead, a variable created in here would really only be available in here. Now, this is not a syntax you use too often because you rarely have the case that you want to suddenly create a variable randomly in some code just in a block. Instead, it's really just in if statements, loops, functions, and so on, where you would need variables that belong to that if statement, loop, and function. But technically, this here also creates a block. And therefore, if I now save this and I reload, you'll see I get an error stemming from line number 8, which is this line where I can't access test. So it's really the curly braces when they're not being used to create an object, but in all other cases that create a block, and then let and const belong to that block and can only be used in there or in blocks nested inside of that block. So if we had a loop or an if statement inside of this if statement, then we could use hobbies in there. If we had an if statement or a loop inside of the greet function, we could use age and name in there. So that's exactly what you learned before with function and global scope. It just isn't only about function or global scope. Instead, that block scope thing is a thing. So that block scope thing really is extremely important and is one of the major changes we saw from ES5 to ES6. Other changes include syntax features which we haven't learned yet, so you will learn them, of course, throughout the course. One other major difference between var and let, which also is yet another reason to use let and const instead of var, is how JavaScript actually read and initialized variables created with var versus how it does that for variables and constants created with let and const. Here's a short example. Let me comment this out and go down there. Let's write some new code so all the other code won't run. And let's write some code here where I console log username, so a variable which I have never created here. And I then, below that log, create username and set this equal to max or whatever you want. Would you expect that this code works? Please note that I'm using var. Now maybe you do because I'm using var and you already learned that var was quite different from let and const, but let's give it a try. So let's reload this page and you see I don't get an error, but I do get undefined here. Now that's interesting. We don't print max, but we print undefined. Now let me change this to let or const, doesn't matter. And now reload this page. Now we get an error. Cannot access username before initialization. So with let and const we get an error, with var we don't. Now why is that? Well, JavaScript has a special feature called hoisting, which in the end means that the JavaScript engine, the browser, when it loads your script, goes over your entire script, and it does things like look for functions, which it then automatically loads and registers so that you can write functions below the code where you actually use them. That's something I covered earlier in the course. It does the same for variables. And for variables created with var, it actually pulls this variable declaration to the beginning of your file. So that's what the browser does invisibly. And then just leaves your initialization, so where you assign a value down there where you really wrote the code. So invisibly, the browser does this. Now, it does not only do that for var, but also technically for let and const. This hoisting concept also exists. But there, the browser doesn't initialize this variable to undefined. It just kind of declares it, but assigns no initial value at all. And therefore, you get this error that there has been no initialization. For var, this is different. There, the browser pulls this up and also assigns an initial value of undefined so that you get no error message, but you have an undefined value here. Now that's one difference, and it's not necessarily an advantage that you could do that with var, because it really leads to a code that's harder to understand. If I'm a developer and I'm reading your code, and let's say you have more code in there, so the declaration is way at the bottom of the file, and I find this line, I as a developer might be wondering, wait, where is username coming from? I didn't see that thus far in the file. And of course, knowing JavaScript, I'm aware that it could be defined somewhere below, but why would you do that? That's really hard to understand. You have to dig through the entire file to find out what's in username. So it's much clearer if you are forced to declare a variable before you start using it, so that you're forced to move your declaration at the top. And of course, you could do that with var and older versions of JavaScript, but you weren't forced to do it. With let and const, you actually are. So that's an advancement. This worked in the past with var, and it still works today with var, of course, but it doesn't work today with let and const. Now with var, you can do other strange things as well, as you learned. For example, you can redeclare the same variable when you already did that in the same scope. So this here would fail if we use let or const, but it will actually work with var. And therefore now if I reload here, you see manual being printed because that's the value of the variable after I redeclared it. Now, as I mentioned before, reassigning a value is absolutely fine and something you commonly do. Redeclaring a variable is something you actually never need to do, and therefore this is something you want to avoid. So that were some behaviors of var which let doesn't support, and I'd say it's a good thing that it doesn't support it. There also are other things in JavaScript. For example, you can create a variable without any keyword at all, so just like this. If you save that and you reload your file, you see max is getting printed here. And that might be strange because I did use neither var nor let nor const here. Now, actually, that's a default behavior of JavaScript because JavaScript is quite a forgiving language. It sees that you missed a keyword here, but in the end, this can only be a variable declaration, and therefore it invisibly adds var. Now, it is something you can rely on in your code, but you absolutely shouldn't. You should avoid things like that because it's just bad code to write your scripts like this. People reading your code might think that maybe you declared this variable username somewhere earlier in this file, and therefore they might go looking for it and never find it, which costs them time. Or that it's even defined in some other script which you import before this script and which would therefore expose username as a global variable. That would be possible, right? So people might think that this is declared somewhere else and might be looking for it when you actually just forgot to add var, let, or const. Now actually, to disable such forgiving behavior, JavaScript has a special mode which you can turn on, and that's the strict mode. It was introduced with ES5, and even though modern JavaScript syntax, as you're learning it in this course, already prohibits some of the things you can rule out with strict mode, it might still be worth turning it on. Though I'll leave that up to you. I typically don't turn it on in this course because I avoid these strange behaviors and we don't write such code. But if you want to be super safe, you can always turn it on in a file or actually also just inside of a function if you wish to, by adding a string at the beginning of that file or at the beginning of that function where you want to enable it. Now that's not a string being stored in some variable, but it's really just a string dumped into the script like this. And in there you put the two words use strict and then a semicolon after this. And you can also use single quotes here if you want to, doesn't matter. Might look strange, but browsers understand this, they pick this up. And they now know that you want to turn on strict mode for this script or for this function where you place this in. So only for this script, not for all scripts on your webpage, just for this script or for this function where it's placed in. And strict mode disables certain behaviors. So, for example, behaviors like this. And attached you find a link with a full list of features or behaviors that are disabled by strict mode. So with strict mode enabled, for example, if you now reload here, you get an error, username is not defined. Previously, that was not the case. Previously, that worked. Now you get an error, which is good because you don't want to allow that behavior here. So let's now add var or even better, let or const again here. Another feature which was disabled is that you could use reserved name and assign values to it. For example, if you used undefined, which is a reserved name because that's a special value in JavaScript, as a variable name, then without strict mode, if I comment this out, this will actually work. If I now reload, this works, we get no error. Now that already changes if we use let or const, and that's what I meant, the modern syntax already disables some of these behaviors, but if I use let or const here and I reload, we get an error that it has already been declared because it's built into JavaScript. And we also would get an error if we would use var, which we shouldn't, but if we would, and we turn on strict mode. If we do that, strict mode turned on, and we use var, and we try to assign a value to undefined. Now if we reload here, we also get an error here. A different error message, but still we get one. So that is strict mode. Turning it on certainly is an option, though as I mentioned in this course, you will already learn patterns and a syntax which doesn't use these bad behaviors. Still, you can turn it on to be super safe. Modern JavaScript with let and const also already prohibits and avoids certain of these behaviors, like this thing with undefined you just saw. And if you want to use strict mode attached, as I mentioned, you find a full list of features which are now disabled thanks to strict mode. And therefore with strict mode, but most importantly with let and const and all the other modern JavaScript syntax you're learning in this course, JavaScript really is a great language where you can write good code. Just be aware that in the past, and of course still in the present, if you don't use const and let, if you don't follow these patterns, it is possible to write pretty messy JavaScript code. It's a forgiving language, and whilst forgiving always sounds great, in programming it typically isn't. Now, JavaScript, ECMAScript, advances in a direction where more and more features are introduced, like let and const, that allow you to write cleaner code, and therefore you should use that. But it is important to be aware of the past and these other parts of JavaScript, which are also part of the language, if you really want to be a JavaScript developer. So let's have a look behind the scenes now at how our JavaScript code is executed and how all these things are working together. So we wrote our JavaScript code, something like that, probably a bit more elaborate and complex, but we got the JavaScript code as we wrote it all the time. Now, we can split the question at how this is executed into two parts. One is, what does the browser do with that code? How does that actually result in something being shown on our screen? And the second part, which we'll also have a look at, of course, in this module, is what the browser does internally with our code, with whatever it did with that, so that it manages the execution flow of our code, that things are executed in the right order, and that our program works the way it should. These are two different questions, as you will see throughout this module, and here we'll start with what the browser does with this piece of code. So we wrote this code, we imported in our HTML file, and therefore the browser reads the HTML file. That's what browsers do. Detects the script import, and then, and that's already something you can memorize or keep in mind, whenever the browser hits a script imported in HTML or written as an inline script in HTML, it will execute it. So the browser comes in and executes our script. Now, what does execute the script mean? And for that, please keep in mind that the exact details, of course, depend on the browser and the engine used. The JavaScript code you write always is the same, but what the browser does with that code in detail, that differs. And if you really want to dive super deep into that, attached you find a couple of links where you can dive way deeper into the different engines and how they work under the hood, though you absolutely don't need to go through that to learn and use JavaScript. It's just a bonus if you're interested in that. So, we're talking about the browser executing the JavaScript code. What does this mean? Well, throughout this course you heard me talk about the browser parsing and executing our code. Now, I'll summarize this in one step. With parsing, I basically mean that the browser reads this JavaScript code, loads it, so to say, and then execution is the actual process where something happens, where our code has an effect. And for that part, browsers have a JavaScript engine. Every major browser has a JavaScript engine. The engine of Google's browser, Chrome, for example, is named V8. For Firefox, it's called SpiderMonkey. And these engines do that parsing and execution, and they typically consist of two parts: an interpreter and a compiler. And the compiler typically is a just-in-time compiler, and I'll come back to what that means in a second. Now, again, the exact details depend on the browser you're using, but that's generally how that works. For V8, so for Chrome's browser, for example, this is exactly how it works. So we then parse our script, which basically means we load it, and we then start execution. And that is done by the interpreter. The interpreter basically loads our script, reads it, it then kind of translates it to bytecode, which is a bit easier to execute, you could say, and then it goes ahead and starts running our script. But what's the job of the compiler then? What is a compiler? Well, the interpreter starts executing our script, but it does so line by line in an unoptimized way, which means the script execution works, but is far from being as fast as possible. To have the best possible performance, you don't just want to interpret the code and basically execute it like this, but instead you want to compile it to machine code and hand it off to your machine, to your operating system, if you will, because that will always be faster. And that translation of your interpreted JavaScript code to machine code is exactly what the compiler does. So the interpreter does not just start executing your script, it also hands off the bytecode to the compiler. So this loaded script in the end, it hands this off to the compiler. Now the compiler is also built into the browser, so it's part of the JavaScript engine the browser ships with. In case of the V8 engine, which works in Google's Chrome browser, the name of the compiler is Turbofan, but that's just a side note. doesn't really matter. So the compiler, whilst the interpreter already started execution of your script, now compiles the script to machine code. Now, needless to say that for very short scripts, the interpreter might already be done, but even then, this compilation step happens. So this happens side by side with the interpreter executing your script. Now, once this compilation to machine code is done, which typically is also relatively fast, this machine code is handed off to your computer, which then may execute it, or which then will execute it. And that's then the fastest possible way of executing the script. Now, the JavaScript engine, the browser, applies a couple of optimization techniques to speed up that execution and compilation time. So for example, code that didn't change between the last execution and the current execution is not necessarily recompiled, but instead the already compiled code is taken again. So if an existing script or a part of the script executes again, it's not necessarily recompiled, but instead maybe the already compiled code can be taken, which of course is way faster than if you go through that interpreter, then compiler, and so on process again. So there are a couple of optimization techniques applied, and again, the attached links allow you to dive deeper if that's what you're deeply interested in. Now, it's also important to note that the browser also gives you a couple of features, so-called APIs, which are built in, which you can tap into from your JavaScript code. Things like working with the loaded HTML code, or for example, what we'll also cover later in the course, a couple of other built-in APIs, for example, for getting the user's location. These browser APIs are part of the browser, for example, written in C++, but again, that depends on the browser you're using, and the browser gives you communication bridges, if you want to call it like this, which you can call from JavaScript. So it gives you JavaScript functions or objects which are just available in your JavaScript code, which you can simply call in your JavaScript code. And when that code then gets interpreted and compiled, the browser knows where to find these functions or objects, it knows where to find these APIs, and it basically includes that call to that native API or to that feature which is built in the browser into the interpreted or compiled code. And therefore, the finished compiled code, which runs on the machine, of course also has access to these browser APIs, because that access or that wish for access, whatever you want to call it, is basically included in that compiled machine code. That's the big picture of how this works and how the browser handles your JavaScript code. I can't emphasize enough that of course the exact steps or the exact names differ based on which browser you use, and therefore definitely check out the attached material if you want to dive super deeply into that. This is the big picture though, which I find important to know if you're working with JavaScript. It never hurts to have a rough idea of what's happening there, but in my opinion it's also enough to know this. Now, again, that's just a big picture of how the browser handles your code, though. It does not really answer the question what the browser does when your code executes. So, for example, how are your variables stored? How does function execution work? How is the order guaranteed, and so on? That's therefore the next step we'll have a look at. So we have an idea of what the browser does with our JavaScript code, how it technically is able to execute that, how it compiles it. But if we take a closer look, if we zoom in into our code execution, how exactly does that work? I don't mean the technical aspects regarding the code getting compiled, but how the different steps in our code, how the logic there is executed. So let's look inside the JavaScript engine, the thing that executes our code. And there, it's in the end all about managing memory and managing execution steps, you could say. And for this, we have two important concepts, the heap and the stack. Now, what are these concepts? What's the idea? The heap is our long-term memory, if you will. It's all about memory allocation. It stores data in our system memory, and with it, I mean the browser does that. The browser manages this heap thing, the browser taps into our system memory, and of course our operating system has a say in that as well. It allocates memory to the browser application, so that's the bigger picture. But if we zoom in into the browser and then into the JavaScript engine, in the end, the browser does this memory allocation in that thing which is called a heap. So there data gets stored with which we work in our program, and important long-term data. And then there is this stack thing. Now that stack thing is in the end important for the execution of our code. Of course the data is also important for that, but the stack is kind of the short-term memory, if you will. It manages our program flow, and mainly that means that the stack keeps control over which function is currently executing, and when we execute a new function, that this function is now executing, and if a function returns, to which function it returns that data. Now this becomes much clearer if we simply have a look at an example. And for this attached, again, you find a very basic starting project with an HTML file that's basically empty. All it has is a script import. And then we have this script. So there are no real elements on the screen. There are no styles. It renders this empty page because now we'll just have a look at some of the behind the scenes things where we can use the developer tools, for example, the console, to get a feeling for what's happening. So now here, let's write a basic program to get an understanding of what's happening. In this basic program here, I want to have a function which I'll name greet. And in this function, I want to say hello. And I don't just want to say hello, I also want to get the name of a user. So I'll have my username constant, and that value should be fetched by another function. So here I'll add another function which I'll call getName. And in this getName function, I return the result of us prompting the user for the name. So your name in this prompt here opens this dialog where we have to enter something, then prompt returns that value, and then I return the value returned by prompt to whoever called getName, which in my case will be greet. So here I call getName, so whatever we enter into this prompt will in the end up in username, and then I output this here in the console. Now last but not least, I just call greet down there. Otherwise, these functions would only be registered but never executed, right? That's what you already learned. This defines functions. JavaScript then registers them. You could say it stores them in the heap because these functions have a long life typically. They live as long as you do something in your application. And here we then call such a function. Okay, so with that, if we save this and we reload this page, I get prompted here. I can enter max, and if I do so, I print hello max here. Now, how does this relate to our stack heap thing here? As mentioned, the functions themselves are basically stored in the heap, so that's where the browser stores these functions and the code it should execute when these functions are executed, you could say. And now when our script runs, the stack is getting active, or to be precise, the browser in the end pushes stuff into our stack. And remember, the stack is basically our short-term memory. Heap is the long-term memory. Now in the stack, it all starts with some anonymous code execution, which basically is the script file itself. It doesn't have a name. Of course, the file has a name, but it's like in a big, gigantic function to which you didn't assign a name. So the code directly in the file is in a function without a name, you could say, and therefore we have this anonymous execution in our stack. So that's the overall script which is getting executed. Of course, that execution of our script only happens after JavaScript evaluated the entire script and, for example, saw all the function definitions. That's what I already explained earlier in the course. So the script execution started. We're executing the entire script. And that basically means that this greet line is getting executed. So we call the greet function. Therefore, JavaScript moves this greet function execution onto the stack. So the stack is in the end a data structure, a short-living data structure, you could say, where your function executions are stored, so to say. So where the browser or the JavaScript engine keeps track of what's currently happening. And the stack is simply populated by pushing new function calls or new short-living data on top of it and popping it off when it's not required anymore. So we started with the overall script execution, this anonymous function, and in there we called the greet function, hence this is pushed onto the stack and is now the topmost item in the stack. And the topmost item in the stack is always the thing which is currently happening, you could say. Now, if we have a look at the greet function, what happens there is that we create a variable, and that variable is created by calling yet another function, the getName function. So now the JavaScript engine pushes this getName function execution onto the stack. Therefore, it now knows this is the currently running function. It was started by the greet function, which in turn was started by this anonymous function, so by our overall script. This is how JavaScript, or the JavaScript engine, can also keep track of the relations of these function calls. So which function called what. So getName is running. Now what happens next? In getName, we return the value of prompt. Now, technically, we therefore also call the prompt function, which of course is not a function written by us, but a function provided by the browser, which we can access through JavaScript. But still, this is a function call, and therefore this also gets pushed on top of the stack. And it would continue like this. The more functions you call, the more gets pushed onto the stack. Now, what happens next? Prompt opens that dialog, and once we entered something there and we clicked OK, or also when we click cancel, prompt actually returns this value to getName. Now, when a function returns or is done executing, it's popped off the stack, which means it's removed from the stack. It's removed from the short-term memory because it's done. Now, important, that does not mean that the function definition is removed from the heap, from that long-term stack. Just this current execution, which of course also involves resources that need to be allocated and data that needs to be managed for this function execution. That data, this execution context, therefore, is removed from the stack. Now in getName, we therefore get that result from this prompt function call. And what do we do with it? Well, we also return that. So getName returns the data to the greet function. As a result, getName also gets popped off the stack. Whenever a function returns a value or simply is done with all its steps, it's removed from the stack. It's popped off the stack. The JavaScript engine does that for us. Now, after being popped off, so getName was popped off, we're in greet. Now greet continues running. We don't have a return statement in there, but once the function executed its last line that's part of the function, it implicitly returns, so it automatically returns. So therefore, once this is done, greet is also popped off the stack, which leaves us with the main script, with the script itself, which you could imagine as being wrapped by a big anonymous function. And now in this script, clearly, once we're done with greet, there's no other step left, right? There's nothing after greet, no other steps left, so we're done with this overall script execution. So therefore, we also pop this off. And that means we're done with everything that needs to be executed at the moment. We can also see that in the browser. Of course, we see the result in the console, but if you go to sources and then to your script file there, we worked with that earlier in the debugging section, you can actually place a breakpoint and place one here inside of getName by clicking on this line number 2 in my case. If you now reload the page, it stops execution at this point of time. And if you now expand this, you actually see the call stack here. This is exactly the stack I was talking about. Not the full stack, because the stack memory itself does actually not just manage function calls, but also short-living values stored in variables. But it shows us the order in which the functions were executed and how they're managed as a stack. And this is just the stack I was just referring to. And here you see getName, before you see greet, and then you see this anonymous thing at the bottom. Now getName is about to call prompt, and we can actually see that by stepping into the next function call, which opens this prompt here. And there, if I enter max and hit OK, well, we're back to getName. Unfortunately, here it never shows prompt being called, but prompt would be pushed on top of the stack as well. And now if I continue here, and I step out of the current function call, for example, we're back in greet. Therefore, getName was popped off the stack. If I step out of this function call, well, then we're back to anonymous because greet was popped off the stack. And if I now resume script execution, eventually the call stack is empty. So that is how this in the end works. This is how JavaScript manages the data and the execution context, the order of execution, and this is how it therefore works under the hood. Now you might remember from the first course section that there I mentioned that JavaScript is single-threaded. Now without getting too technical, that basically means that JavaScript can only do one thing at a time. That's exactly what happened here. It called one function at a time and the other functions waited for the response of that function, just as you saw it in that stack. So the stack and this idea of managing our function calls and the flow of the script therefore in such a stack, that basically ensures that this single threading thing works and that the order of execution is ensured and that every function basically knows to which function it relates. Now there is one other important concept which is actually not part of the JavaScript engine, but of modern browsers like the Google Chrome browser, but also of other browsers. And that's a thing called the event loop. This will actually help us with asynchronous code, which we haven't really learned too much about yet. It helps us with things like event listeners, these click listeners which we added to buttons. The current picture which you have here, where we have this stack which does stuff and which eventually is empty, kind of implies that a script always has a certain point of time where it's just done with everything, just like this script actually is. It's done after line 10 executed, but that's not necessarily always the case for all scripts. What about a script like this? And you find this setup attached as well. It's this index.html file, which has a bit more content. It has 2 buttons and this app.js file. Let's not worry too much about what's happening here. I'll come back to this script and about an issue which it actually has later in this module. But the main thing which is important to us right now is that here we're actually adding event listeners. We're adding event listeners here to buttons. And that, of course, therefore means that if we would actually execute this, and I remove this breakpoint here, and instead I set a new one in app.js, and I set one here at the end at line 14 when we register this event listener, and now I reload, well then of course execution pauses and we have our call stack down there. Right now I'm not pausing inside of a function, so the anonymous wrapping function is the only thing on there. And if I resume, the call stack is empty here as well. Now this would imply that this script is not able to do anything ever again. And still, if we go to the console and you enter something here in the input, click add a listener and then click me, you see this actually still does something. This output here is coming from our script from line 7. So this script is still alive even though we're at the end of it and even though our call stack is empty. So that can be confusing. Why is that happening? Well, that's exactly what that event loop is about. We'll dive into that in way more detail later once we learned more or learned something at all about asynchronous code in JavaScript and what this is and what the opposite is. For now, you can just keep in mind that there is something else in the browser, not in the JavaScript engine. The engine is really just that heap stack thing. But in the browser, which communicates with the engine, of course, which is this event loop. And in the end, you can imagine these click listeners as information being passed to the browser. So therefore, the JavaScript engine does not care at all about these ongoing listeners. The browser manages them. And the browser basically pings the JavaScript engine, you could say, whenever it has a new event being fired by the listeners set up by the JavaScript code. So the browser kind of manages these listeners. And whenever such a listener triggers, whenever a button is clicked, which of course is part of the web page rendered by the browser, so the browser knows when that happens, whenever that happens, it basically pushes that information to your script, you could say. And it does so with the help of that event loop, which is there to control that this pushed event does not interrupt with your ongoing script, which might be running, but instead is executed in order once your call stack is empty. But again, we'll have a detailed look at this event loop thing in a later module after we learned about asynchronous code. The JavaScript engine itself is this heap and stack thing here. Now that we know about the heap and the stack, it's time to dive into a super important concept, which even if the rest is not interesting to you, you absolutely have to understand because it's super important for JavaScript, and it can be very confusing when you work with JavaScript when you don't understand this concept. It's about primitive versus reference values. Now, what is that? In JavaScript, we have two categories of types or of values, you could say. So with that, I don't mean strings and numbers, because that would be wrong. We also have booleans, objects, null, undefined, and so on. But I really mean these data types, which you already learned about. So booleans, strings, numbers, and objects, and so on. These can be categorized into two categories. We have primitive values, and we have reference values. And that's an important differentiation which you need to understand. Now, primitive values are these 6 types of data. Strings, numbers, booleans, null, undefined, and symbol, which we haven't learned about, which we'll learn about later, which is very advanced. It doesn't matter right now. These are primitive values in JavaScript. So every number that you create and which you then store in a variable or which you use in a calculation is created by JavaScript or by the browser behind the scenes as a primitive value. Thus far, that didn't really matter to us, and in many cases it won't matter to you, but there will be one important difference to the reference values later. So it's stored in memory, normally on the stack, because normally these are relatively short-living, because JavaScript can get rid of them relatively easy. They're cheap to be recreated, so it can easily duplicate them. This doesn't cost too much, not much memory is consumed by these values in the end. And therefore, they're typically stored in its stack memory. Now, if you keep that picture in mind where function calls are pushed on top of each other, remember that I called the stack a concept for managing execution contexts. Well, you could say each function there has its own execution context, right? The overall script has some global variables maybe, which are part of that anonymous execution context. Another function, which has an internal variable, has its own execution context. So primitive values typically are stored in the stack. I'm saying typically because they could be stored in the heap as well if it's a long-running operation. And in the end, it's the browser which decides which data ends up where. It actually doesn't even matter for what I'm explaining here. I just want to briefly mention it here that these primitive values are generally managed in the stack. More important to us, and the key difference between primitive and reference values, is that when you copy a variable, which means you assign it to a new one, which holds a primitive value, then the value is actually copied. Now, we took this for granted thus far, but the implication is quite important. If you open up your browser developer tools console on any web page you want, maybe the one we just worked on or a brand new one, doesn't matter. In there, if you create a variable with let, let's say you name it name, but that does of course not matter, you can name it however you want, and you store a value of max or any other string in there, then this obviously is a primitive value as you just learned. Strings are primitive values, and therefore, well, max is stored in there. If you now create another variable, another user or whatever you want to name it, and you assign name as a value to that variable, then you're basically telling JavaScript, take the value stored in name and store it in another user. Therefore, another user, of course, also has max as a value. Now it gets interesting if we now change name to, let's say, Manuel. So we assigned a new value to that variable. If we now look into another user, though, we see that still stores max. And this kind of is what we expected and what we used thus far throughout the course. Whenever we took some value in a variable or maybe in a parameter of a function and we stored that in another variable, it was always clear to us that if we changed that original variable, the other variable where we stored it in would not change as well. And that's the case because primitive values are copied by value, which means when we do this assignment here, we're telling JavaScript and the browser, hey, take the value which is stored in name in this variable, create a copy of it, and store that copy in another user. Don't forget that all data, including strings and numbers, needs to be stored in memory somewhere. Now, as I said, typically that's the stack, and we don't have to worry too much about where exactly it is. But because it needs to be stored somewhere, it's not obvious or not something we could expect that JavaScript always creates a copy when we want to store it in a new variable. It could also just tell the variable, well, take that exact same value in memory, stored in the same place in memory, and store this address of that place in memory in the variable instead of the value itself. And if that would be the case, then changing variable 1 should also impact the value stored in variable 2 because they're effectively pointing both at the same value. But that's not what's happening with primitive values. Instead, there a real copy is created. So that's the behavior for primitive values. Now you can probably already guess what the behavior for reference values will be, but let's still have a look. What are reference values to begin with? Well, all our objects, or generally all objects in JavaScript. Now, technically, if you want to be really correct, string numbers and so on are not objects, but are dynamically transformed to pseudo objects, you could say, when you do something like name length. We have used that before in the course, but this gives you the length of the name, and with the dot notation, it kind of implies that we're accessing a property of name, which then in turn implies that name would be an object. But it actually isn't. It's a bit more complex than that, and we don't need to dive in all the internals here. But in the end, what happens here is JavaScript dynamically transforms a string or a number, so any primitive value, to an object temporarily if you use the dot notation on it. But other than that, it's a primitive value. And it's always behaving as you see it here on the left, no matter if you're temporarily transforming it or not. Now, all real objects, which always stay objects, are handled differently. Because they're more expensive to create, you could say. A real object, which you create on your own, or which might be built into the browser and exposed to you, like that moth object where we also called it the random function earlier in the course. Well, these objects, as you can imagine, hold a bit more data than just a couple of characters or just a single number. They're more complex to manage, and therefore creating them takes longer, occupies more memory, and so on. Therefore, the browser typically stores these in the heap, but again, the exact allocation logic is something the browser is responsible for, not you or JavaScript, but that's what the browser does. And important, a variable then only stores a pointer, so the address of that place in memory, and not the value itself. For primitive values, a variable really stored the value itself in it. For reference values, that's not the case, and instead the value is stored somewhere in memory, somewhere in the heap, and the variable stores the address of that place in memory, so a pointer at this place in memory, you could say. Therefore, if you copy a variable which holds a reference value, so if you assign it to a different variable, you only copy the pointer, the reference, and not the value itself. Now, what's the implication of that? Let's go back to the browser and reload. And now let's create a new array, let's say. And arrays are just objects. So here I have my hobbies array, which currently only includes sports. And now let's create another variable, new hobbies, or however you want to name it. And let's store hobbies in that by assigning it like this. Now if we output hobbies here, we see that's the sports array. And new hobbies, of course, also is that same array. So thus far, you could think that the value was copied. Now let's actually go to hobbies, so to the original array, and push a new element onto it. Let's say cooking. So this new string is pushed onto hobbies. So if now I output hobbies, I of course get that array with sports and cooking. But as you now probably expect, new hobbies also includes cooking, even though we never touched new hobbies. But it includes this value because when we assigned hobbies to new hobbies, we only copied the pointer. We only copied the address of that array. So the element itself, the value, the array itself was never duplicated or copied. Instead, we only copied the address. And that means if we change one array, we automatically change the other array because there is nothing like one in the other array. There only is exactly one array in memory. And then both variables hold the same pointer. at that place in memory. It's the same for objects, by the way. If we have person here, and this person, let's say, has an age of 30, and then I have another person, and I assign person to that. If I then, to mix it up, go to another person and set the age here to 32, then if we have a look at person, we see there the age changed as well, for the exact same reason. Now, what can we do about that? Well, in general, you don't need to do anything about that. That is a default behavior for a good reason, to avoid unnecessary duplication of data, to avoid cluttering your memory, to be more efficient, provide better performance, and so on. But of course, you sometimes have cases where you need to copy data, where you need to store it somewhere else, and where you want to make sure that if you added the copied, in quotes, because you're not really copying it, so when you're editing the copied data, that the original data isn't. Now, we'll have a closer look at solutions in the arrays and objects deep dive sections, which will come soon after this one, where I explain a bit more about the solutions and how they work. For now, I'll just quickly show them to you, and we'll dive into the details later, because right now we don't really need that in the course, but I also don't want to hide that solution from you right now. So let's say we now want to create a real copy in yet another person in this variable, and there I want to copy person. Now, as you learned, like this, it wouldn't work. Now, you can use a different syntax, where you create a new object with curly braces, right? This creates a brand new object. And if you do so, then you can add a brand new operator, which we haven't used before and which I'll cover in more detail in the objects and arrays sections I just mentioned. It's 3 dots, which looks rather strange, but this is a operator built into JavaScript. It's called the spread operator. And after that, you can add person. Now, what this operator does is it pulls out all the key value pairs in person and adds them as new key value pairs to this new object. And since this is a new object, it's a real copy. It's a new place in memory, new address. The old person also still is there, but this also is now a new object. So if we do that, then yet another person, of course, has the age of 32. But if we now change person age back to 30, you'll see yet another person still has an age of 32 because now this was a real copy. Now for arrays, a similar approach exists. If we have our hobbies here with sports, and then we have more hobbies and we want to create a real copy, then we create an empty array, use that same spread operator, so the 3 dots, and then that existing array, and now just as it pulled out the key value pairs for the object, here it basically pulls out all the elements of the array and adds them as elements to this new array which we create with the help of the square brackets. So therefore now, if I go to hobbies and I push cooking as a new hobby onto that array, you'll see that more hobbies still only has sports. Again, that's the quick introduction to that solution. A closer look at the spread operator will be taken in the arrays and objects modules. So now that we covered reference and primitive types, we can also dive into something else, which I already showed earlier, but where we had no great explanation of why that was happening. I'm talking about a use case where we have maybe a person, let's name it person 1, where the age is 30, and then another person 2, where I don't assign person 1, but I instead create another new object with curly braces, where the age is also 30. So to us, these are exactly the same objects, and still, if I perform a Boolean comparison here with either 2 or 3 equal signs, doesn't matter, you see the result is false, so they're not equal. Well, now this makes a lot of sense. Keep in mind that what we actually store in person 1 and person 2 is a pointer at a place in memory. And these are 2 totally different objects, even though they hold the same data, but they are 2 different distinct objects stored in different places, so at different addresses in memory. And since person 1 stores the address of this object, and person 2 stores the address of this object, and these are 2 different objects, we have 2 different addresses. And therefore, if we compare person 1 to person 2, what we effectively compare is whether the address of person 1 is equal to the address of person 2, and that is not the case. This is why we get this false result here. This is why they're not equal, because of that reference type thing. And it's the same for comparing arrays. Another important implication, which also can be confusing when you work with reference types, is this one. Previously I created hobbies with let, right? Now here's something which might confuse you. If I create it with const hobbies, and I have an array there which includes sports and nothing else, then let me try to push something onto hobbies. Let's say cooking. Would you expect that this works? Keep in mind that it's a constant, so we can't change the value after it has been created. Well, you might expect an error therefore, and yet if I hit enter, we get no errors, and if I have a look at hobbies, we see cooking was added. So how does that work? Well, again, keep in mind, this array gets created somewhere in memory, and what's getting stored in hobbies is the address of that array or of that object. Arrays are objects, as you learned, so the address is getting stored in this constant. Now, when we call push, we certainly do manipulate the data in memory. But what do we not manipulate? The address. It's still the same address. The data in memory changed, but it's still at the same address. Maybe more memory was allocated to it. That's something the browser does. But we don't care. We don't care if more memory was allocated. The address is the same. So in this constant, the value never changed because the value is the address and the address didn't change. Just the data behind the address, but that's not what's getting stored here. Therefore here, we can change this like this without getting an error. It's different if we try to assign a new array like this here. Sports, running. If I try to do that, I will get an error. Why? Because we use the equal sign here. And that means we try to assign a new array. Now, of course, as you learned, the array will never really be stored in there. But what matters is that we do indeed create a brand new array here, which means a brand new place in memory, a brand new address, and therefore JavaScript tries to store a brand new address in hobbies. So now the value of hobbies would get changed, and that indeed is not allowed because it's a constant. So using constants with a single equal sign to assign a new value is never allowed. But changing the objects which might be stored in them, that is allowed as long as you use something like push. Now, of course, you can't change primitives stored in constants because these are not stored in memory and there is no address stored in the constant, but instead the real value is stored in it. But for objects and arrays, this works. So just to also give you an object example, if person would be stored in a constant and I set the age to 30, I can of course output it, but I can also access the age and set it to 32. And if I now output person, this would work because now I only change the data in memory. You could argue that I am using the single equality operator, so the assignment operator here, but I'm using it on age, not on person, right? I'm not saying person is equal to something. That would fail. If I set person to a new object, this would fail. But I'm setting age inside of the person to a new value, not person itself. So I'm only setting a part of the data stored in memory to a new value, just as we did it with the array a second ago. And therefore, the data in memory certainly changes. The address does not, and therefore the address stored in the constant person also does not change. I'm really emphasizing this because it is such a crucial concept and that can lead to a lot of confusion. Constant arrays and objects which suddenly change are a common source of confusion, and the same is true for data which you change in place A and it suddenly also changes in place B, because people forgot or never were aware that there is something like reference values, which really matters a lot because it explains all that behavior. So this is a must know when you work with JavaScript, and I hope that these lectures really made it clear what primitive values and reference values are, how they work, how they behave, why they are important, why they are useful, and how you work with them. So we spent a lot of time on the internals of JavaScript, but this does matter. If you're working with a language, you need to understand at least a bit how it works under the hood so that you can optimize your code for it and you're not surprised by strange behaviors. The last important concept I want to have a look at here is the concept of garbage collection. Now, let's ignore the stack for that. The stack is short-living memory, and as you saw, the stack is cleared automatically because items function calls, execution contexts are popped off when they're done. But what about the heap, that long-living memory? How is this memory managed? It's important that it's managed because otherwise it might overflow at some time. The operating system of your computer, of your machine, of course only allocates a certain amount of memory to Chrome, and if that would be exceeded, it would simply kill Chrome at some point of time. Now actually, that will never happen because Chrome also has internal memory management, and it will simply kill your website before it occupies too much memory. So you want to avoid that. And the good thing is, you don't really need to actively manage memory unless you're building super complex, three-dimensional, calculation-intensive applications, which you might want to build in totally different ways to begin with. So let's ignore that. But still, there are some things which you should keep in mind and which you should understand. How does Chrome manage this memory? Well, there is a thing which is called the garbage collector. Every JavaScript engine has one. So here, let's say we're talking about V8's garbage collector, which is the engine, the JavaScript engine Chrome ships with. But of course, Firefox and so on, the engines built into these browsers also have a garbage collector. Now, what does the garbage collector do? And just a quick note, in case you have a night where you really can't sleep, attached you find a detailed document of how the V8 garbage collector works, in case you're interested. And you can therefore definitely check out this document if you want to learn all the nitty-gritty details. I'll not dive that much into detail here, because again, that really is beyond the scope of this course. We're not trying to build our own browser, we're just trying to understand what the browser, what the JavaScript engine that is part of the browser does for us. So what does this garbage collector do? In the end, it periodically checks the heap memory for unused objects. And unused objects are objects without references. Now remember, references are these things, the addresses in the end, which are stored in variables. And therefore the garbage collector will go ahead and basically remove, clear all unused objects from the memory, from the heap memory. All the objects where it sees that you certainly won't work with them anymore in your code. Now that's great. Let me show you an example. Still, this is this mini app or this mini demo which we started working on a few lectures ago. And in there, let's add a new variable. Let's say a variable person. Now we don't need that for this application or for this demo here, of course, but let's say in some app we had this person variable. It holds an object with a name of Max, let's say, and therefore, since this is an object, this is of course a reference value, and this is stored on the heap. Now, as long as we have this variable, the person variable, holding the address of this object, JavaScript sees that we hold a reference to this object, that we're interested in its address. And as long as that is the case, JavaScript will not clear that object from memory. Instead, what JavaScript is looking for, whether there are any variables or any places in your code where you're referencing an object like this one. So when would garbage collection kick in? Well, in this example here, as soon as we, for example, set person equal to null. What we do here is we assign a new value to this variable, and the consequence of that is that this object here is no longer referenced by anything in this script. There is no place in the script where we would be interested in its address. This address is not stored in this variable or anywhere else. And JavaScript detects this and sees that this address, this pointer to this object, is not used anywhere, that you have no variable or no other place in your code where you're referencing this object, and it can now clean this up. Now actually, the way modern browsers, modern JavaScript engines work is such that even objects, arrays, which are also objects, and so on, which are stored in variables which you created with let or const, can be cleaned up by modern browsers with modern JavaScript engines, therefore, if you're not using these variables anymore in any place of your script. So you don't have to set a variable to null to let the browser clean this up. If you're not using the variable anymore, that will also be picked up by garbage collectors. So these are just different examples of when the garbage collector kicks in and will try to free up memory. Now, it will not instantly do so once you set person equal to null. The JavaScript garbage collector can't be triggered by you. You can't force JavaScript to go ahead and garbage collect. Instead, it will run its algorithm, its logic for that. And by the way, attached you find a resource which allows you to dive deeper into the internals if you're interested. It will do that on its own schedule, following its own logic, but it will eventually pick this up and clear this from memory. Now that's a good mechanism, and as I mentioned, you generally don't have to do anything for that to happen. You don't have to tell the browser that it should go ahead and do garbage collection, for example. It will try to do that in a smart way without interrupting your web page or without slowing it down, without being visible to your users. Now, you should still beware of memory leaks. That is when you actually write code where you have a certain object which you don't work with anymore, but you still have a reference to it. So you still have some variable or some place in your code where you still hold a reference to that object. And even though you're not interested in it anymore, it's still there and there still is a reference to it, and therefore it can't be garbage collected. Because even though you don't want it anymore, you wrote code that doesn't make it clear that you don't want it anymore. So you basically have a bug in your code. And in this little application, there actually is an example for this. Let me show you how we could actually introduce a little bug here in this application. We have two event listeners here, right? This event listener here at the bottom executes or is set up when this script executes. This other event listener here is only set up when we, trigger this first event listener, because this first event listener is attached to this add a listener button. And when we then tap this button, we trigger this add listener function, which sets up the event listener on the other button, which is that click me button. So the click me button only gets an event listener once we clicked the other button. Now, when we then click that click me button, we in the end execute print message. Now, if we have a look at what that yields, here, if we open that in the browser, we can see that if I enter something here and I hit click me, nothing happens, nothing appears here in the console. If I click add a listener though, and then I click me, you see test getting output there, one test for every click. Now if I change that text, we see that text being output. Now if I click add a listener multiple times here, I still only see one output per click on click me. So it's not the case that this print me message would run more often, because you could think we're adding more and more event listeners to this button. So with every click on that add a listener button, we add a new listener to the click me button, and therefore we might see this function being executed more often for every click, but that's not what's happening. And the reason for that is that JavaScript here is really smart, or the browser and JavaScript together. And if you add an event listener to a button or to any element with an event to which you listen and a function which you already used before, JavaScript will replace that old listener with the new one and not add a brand new one. And that's a good behavior, because otherwise you could easily end up with hundreds of event listeners on the same object, and that would probably lead to a behavior in your app which you don't want and introduce memory leaks, because you're populating your memory with all these functions. And functions in the end also are just kind of objects, and they're therefore also stored in the heap in memory, and they, clutter up that memory over time. So it's good that the browser doesn't allow that. Now we can actually trick the browser if we copy that function and replace print message here with that function and remove that name. Now, we haven't seen that before. That's a so-called anonymous function. We'll dive deeper into that in the functions module. And whilst this might look strange, what this does is it creates a function here in place. It just doesn't assign a name to it, but it's still getting stored in memory. And the pointer to that function, the address of the function, is simply then passed in as a second argument to add event listener. So this function is created on the fly, so to say. It's not getting executed immediately or anything like that. It behaves just as when we pointed at print message. But the difference here, and that's a crucial difference, is that this function doesn't have a name, and it is indeed created as a brand new object whenever this add listener function runs, because this function is created here on the fly. Previously, this print message function here was only created once when this entire script ran for the first time. Then this code never runs again, and therefore only one function object is created. Here we create a new one whenever add listener runs. Well, and the behavior we see therefore is that if I enter something here and I add a listener and I click me, we got the same as before. But if I click add a listener multiple times here, we see more and more outputs printed for this test thing here, for click me, right? So we see more and more outputs being printed, one for every time I clicked the add a listener to the other button. And that simply is the case because a new function is now created for every execution of add listener. This is dangerous, or a potential problem at least, because that can lead to memory leaks where you have dozens or hundreds of function objects in your memory and JavaScript is not able to clean them up because every execution of add listener creates a brand new function. To JavaScript, this is a brand new object, not the same as before, and therefore it thinks, okay, you want to add a new click listener with a new function than you did before. It doesn't see that the function does the same thing as the old function. To JavaScript, since we create a new function, it is a new function. So that's something you should be careful about. Now, this is a very rare and constructed scenario here, of course, and we'll dive deeper into anonymous functions, into event listeners, and also into performance management later in this course, but it is something which I want to highlight here, so that you understand the importance of the job of the garbage collector, that it does a lot for you, but that it's also not some magical tool that can rule out any errors you introduce. Now again, we'll dive deeper into this and also how you can find and fix memory leaks later in the more advanced parts of the course. So you don't need to worry about this right now. In most cases, you don't introduce such leaks because it's not that easy, thankfully, to add them. The garbage collector is really smart. Just still important to mention it right here. So in this module, we had a thorough look at JavaScript's different versions, its past and its present, at var and let, block scope versus function global scope, the implications of that, strange behaviors you could implement, especially when using var, and strict mode to avoid that, though as I mentioned, using let and const already prohibits a lot of these strange behaviors, and in general the syntax and the patterns I show you in this course will use none of these strange and actually to be avoided patterns and behaviors. And besides all these language specific things, you also learned a lot about how the browser actually handles your code, how it interprets and compiles it. You learned how your code executes with the help of the stack, the heap, and what the JavaScript engine does with these things. You learned about primitive and reference values, important concepts which can lead to a lot of confusion if you don't understand them, which is why I covered them with great detail in this module. And we also finished this up with a look at garbage collection and how to avoid memory leaks, though as I mentioned we'll have a whole module later where we dive into performance optimization and avoiding memory leaks in JavaScript programs. So that is a look behind the scenes of JavaScript, a look into its past, into its weaknesses and potential fixes for it, like the modern syntax, strict mode, and so on, and what the browser actually does with our code and how it works internally. That is super important to know if you want to be a JavaScript developer, because you need to know your language, you need to know what it does, and you need to know how to write proper code. For all of this, this module hopefully was very helpful. With that, let's go back from the theoretical side here, back into more code and into more language features which we can use in our scripts.